Okay, in this problem, I would like to use the PEO or Catia's Product Engineering Optimizer to solve the following problem. Suppose we have a rectangle with sides A and B, where we know that the perimeter of this rectangle is 20 millimeters. Okay, so basically what it means is that 2A plus 2B is 20 millimeters. Okay, what we like to do is to find A and B such that the area is, which is incidentally AB, the area is maximum. Now, as I mentioned in the earlier video segment, the preliminary video segment, A and B are physical entities. In this case, they are dimensions, the size of those sides. And therefore, what we like to do is specify some range for them. For example, we know if there is to be a rectangle, A must be bigger than 0. A equal to 0 will give you basically a flat line. And let's say that we are interested only where the range of interest is A between 0 and 6. Okay, and for B, it's between 0 and 6. Now, let me remind you that this problem was done by you in your calculus class, and all you do is to calculate A, for example, or B from the perimeter expression, and plug it in the top one, so everything is in terms of A. Here is the way you did it in your calculus class. AB is the area, 2A plus 2B is 20, so you solve for B in terms of A, it's 10 minus A, and substitute it in the expression for area. It's going to be like that, and area is this. So to find the maximum area, you differentiate it with respect to A, you get that, and you set it equal to 0, and therefore A equal to 5, B equal to 5. I also pointed out that in the preliminary video that this can be done with Lagrange multiplier method, but right in your first year calculus class, you don't have a Lagrange multiplier, therefore this is how you solved it. Now, what we like to do is to solve this problem with Catia. Ask Catia to solve it for us. So the first thing that you do is you go and create a surface being a rectangle that we're going to calculate its area down the road. All right, so let's see now. On this vertical plane, I will sketch a rectangle, something like that, and I'm going to dimension it. So dimension this and another one, that guy. Now, let me change these things to some smaller numbers. For example, like maybe 30 and maybe 40. It's really irrelevant, but I just didn't want those big numbers. Okay, now we exit. I want to put a surface here, so I do remember I'm in wireframe and surface design or generative shape design. You can do the same thing in wireframe and surface design. Generative shape design workbench. You fill this, and there we are. So we have a surface which is obtained by filling. Now, I'm going to hide the sketch and extract the boundary of this rectangle. By the way, before I go any further, this is not the only way of doing this problem. This problem can be done in many, many different ways. I'm not claiming this is the easiest one or this is the best one, but that's the approach that I'm going to take. So I'm going to extract the boundary of this surface. Now, as extracting is done, if you look at the extraction, it is in the same toolbar that says operations. And let me see now, right here, right there, extract. And I'm going to select one edge, but I don't want just this one edge. I want all the edges. So don't say no propagation. Change this thing to point continuity, and that means extract the whole thing. Okay, good. So we really have two curves, two things here. we have this this extract is what you see over there, and the sketch is hidden, so what you see there is actually extract. So for example, if I hide this, this is the extracted surface, extracted boundary. Okay, let me bring it back. All right, now the next thing I want to do is to create 4 parameters. These parameters are A, B, perimeter, this is the perimeter, and area. Okay, so let's go ahead and do that. Now, let me remind you how we create parameters. So we go to f of x. Let's do the 3 parameters which are of type length first. So this is length, new parameter. I'll call this thing A. Okay. Now, I want to say that eventually, right now it's going to be 0. It's going to be value 0. I can change that, of course, but don't worry about it. So let me do another one. B. Again, it says 0, but we're going to change that so that it becomes the value of the side. Okay. Apply. New perimeter. Okay. Apply. The next one is going to be area. So you have to change the type of this. See this? You have to go and select area is area type of the parameters area. Where is this thing? Let's see, area right there, and new parameter. I'll call it area. Okay, and then apply. Okay, so now what I'm going to do is I'm going to click on the sketch. Click on the sketch. So one of these is going to be A, the other one is going to be B. So I select this value, this dimension from the screen. And once again, remember there are many different ways of doing this. Add a formula equal to A. Rename parameter equal to A. Don't forget to double click or type it. Now notice that this changes color because the value of A that I have is 0. So, you know what, maybe what I should do is change this thing from 0 to some other value, because I'm going to get an error message saying that, hey, if your A is 0, I cannot do the surface for you. Okay, so let me change that thing to, I don't know, maybe 20, I'll change that thing to 20, okay? Say okay. Because if I say this dimension equal to A and the value of A was 0 because I neglected to change that value to something meaningful, I'm doing it right here. Okay, good. And then this one, add a formula. I want to say it's equal to B. The problem is that when I do that, B is 0, and then I'm going to get an error message about the rectangle not being able to be filled. So rename parameter B, and again I'm going to make this thing, I don't know, some other value. It's totally irrelevant. 40. Okay. Then I'm going to select from these parameters that I created. See these parameters that I created. Incidentally, if you don't know how to show your parameters in the tree, okay, let me close this. A and B have been created, no problem. If you don't know how to get these things in the tree, and I'm pretty sure that if it's the first time you're doing parameters, you're not going to be able to see that. So you go to Tools, Options, okay, under the infrastructure, you see Part Infrastructure, and you click on the Display. Notice that these have to be checked. For example, let me uncheck them and show you what happens. No, we don't need all of them. You need constraints and parameters and relations, G. There, you see that? Although you created the parameters, and you can see that if you go to f of x and you say, show me the rename parameter, you get the stuff. but they don't show in your tree. So what you do is you go Tools, Options, Infrastructure, Part Infrastructure, Display. You really need constraints, your parameters and relations. You don't need these things, but I checked it anyway, so that's fine. There, you can see that the parameters are showing on, and the equations that are created. Remember, I said that that dimension equal to A, that dimension equal to B, and those are the relations. Okay, so let's go to the rest of the problem. Okay, so here are the renamed one. Okay, so we say perimeter, add a formula. Now, we want to say that the perimeter is equal to the perimeter, the length of this extracted curve. So let's see, look under measure. You want the length of a curve right there. See that? You double click on it, and then it says what curve. It leaves the entry between the two parentheses blank for you so that you can fill it. So you go and click select extract. There, I double clicked on it so that it puts it up there. Okay. What this is saying is that the value of the perimeter has been changed basically, because remember I started with something and then I made change the values of those dimensions, but that's okay. Just say yes. Okay. All right. Good. And then area, add a formula. Once again, go to measure. Where is measure here? And look at the area of a surface right there. Area of a surface. See that? Right there. Area of surface. Double click. So it types it there. And it leaves the argument blank for you to fill in. So you go and select the fill. What you do, you type fill 1 or double click on the fill 1, double click, left double click fill 1 from the tree, and it puts it right there for you. Okay? And we say okay. And it says, do you want to modify? You can modify the behavior with the relation properties. Say yes, and okay. All right, good. So you can see that A and B are 20 and 40 because I typed those values and the perimeters of these things, perimeter and the area, and then apply. Now apply and then okay. Okay. So notice that I have created 4 parameters here. Okay. A and B are those dimensions, equated them to those dimensions, and then perimeter eventually is going to be 20, and area is we want to maximize. Okay, good. All right, so now we're going to say, let's save this thing. File, save management, save as. On my desktop, we create a new folder, and I put okay, so put maximizing. I'm going to create a folder here, maximizing area. Okay, good. All right, now we're going to go to start, knowledgeware, product engineering optimizer. And over here, you have 3 choices. There is the optimization, there is a design of experiment, and constraint satisfaction. Now, the only one that we use in my tutorial is this sequence of tutorials optimization. You click on it. Okay, so here's the situation. It says, first of all, what do you want to do? Minimize or maximize? I want to say maximize. Then it's going to say, okay, what is it that you want to maximize? I select You click and you select, and it is the area that I want to maximize, right? Right there, the area I want to maximize. Double click on this. Right now, the area is 40 by 20, which is 800 millimeters square. Okay, good. Then it says, what are your free parameters? So you click on the edit list. A and B are my free parameters. So send A to the right, double click on B, send B to the right, and you say okay. So notice that A and B are uh, declared as free parameters. Now, you can specify the range of A and B. And the range of A and B, according to the slide that I have here, is between 0 and 6, 0 and 6. Now, when I do this, of course, it's going to complain that, wait a minute, you have 20 millimeters. Are you sure you want it to go between 0 and 6? The answer is yes, because it will adjust that to put it in that interval. So you select this line, double click on it, and check all of these. For nth range means the smallest range, so it's going to be 0. This is for A I'm doing, and the maximum is going to be 6 millimeter. And there's something called step here. For now, I suggest you put a 1 millimeter. Okay, so basically, the algorithm that we're using, simulated annealing, is a search process. And search process, the step will tell you kind of how many search points you're going to have. The smaller the value of step, the more refined the answer is going to be. Okay, good. I say okay. What this is saying is that, wait a minute, what you have for A right now is not in this range. Are you aware of that? The answer is yes. You know that. And notice that it did change that value that I had from 20 to 6, and it changed the size of this too. When I do the next one and then I say apply, it will actually get rid of this red stuff. Okay, so double click on the B on this line, and again 0 and 6. This is 0. This is 6. 1. Okay. Again, it's out of range. Are you sure? The answer is yes. It's right now. You can see that. Okay, good. The algorithm that you're using is simulated annealing. You're not using the other ones. You want a fast solution. There's fast, slow, slowest, etc. So depending on the type of problem, you may choose fast or slow. And then the maximum number of updates, 200. We use the default. Consecutive updates without improvement, 50. And maximum time in minute 5 minutes. This is going to be a fast problem. So even if you put 1 minute, it's going to work. But there are certain problems that you may have to change that. Maybe it's coming from a finite element problem. You have to repeatedly solve the problem. Now, the other thing you have to do is to make sure that the optimization data is saved. Optimization data is saved. This, if you're doing it the first time, this may not be checked. So check it out. Okay. And everything else is okay. Now, we have a constraint. So notice that there's a constraint tab right there. Oh, by the way, this was minimized, right? Maximum. Sorry, maximum. It was maximum. Maximum area. Select the constraints tab, and we want to add our constraints. So we say new. It says, okay, what do you want your constraints to be? Well, I want perimeter to be equal to is like that. If you ever wonder how did I know that, you can click on operation. Equal means this, okay? And this is equal to 20 millimeter. I want the perimeter to be 20 millimeter. Don't forget the mm, because if you don't, it's going to complain that, wait a minute, left side is a millimeter, right side has no dimension. Well, this is why you have to put 20 mm. Okay. All right. So yes. Okay. Now, by the way, notice that in the constraints tab, this says the constraint is not satisfied because I believe my A and B were 6 and 6, right? And 2A plus 2B is 24. The perimeter is based on 6 and 6 is 24. Therefore, I want it to be 20 or equal to 20. I'm going to come and talk about this thing later on, by the way. Now, there is this, So let's go ahead and go to problems. Okay, problems tab, and I think we are good. All right. Uh, Let me also select with visualization update and then run it, run optimization. As soon as you try to do that, it'll say, okay, you told me that I want to save, or you want to save the results. Where do you want to save it? Well, I want to save it in that same folder. It's an Excel file, so Excel, I'll say, I'm not going to say Excel, I'm going to say max area rectangle. Say save, and then it's going to start running. This was the time, 5 minutes. It's never going to get there. This is the maximum number of iteration, and it reached and stopped. Okay. So first of all, notice what happened is that it looks like I started from 6 and 6. It's down to 4.855 and 5.145. That's good because the solution had to be, remember, the solution had to be 5 and 5. Okay, so that's pretty good. But what I can do is that to improve the results, what I can do is I can go back and rerun it with a smaller step. Remember how the step was defined right here in this line? Double click on this. Instead of 0.0, instead of 1 millimeter, I make it 0.1. And here, again, instead of 1, I make it 0.1. And we say OK and run it. Okay, there is some improvement, not significant. We'll talk about that thing later in a minute. And notice that the area, the maximum area that theory calculus from your calculus class said that is 5 times 5, that's 20. 25 is now 24.979. That's pretty good. Okay. Now, first of all, you click on the computation result. Now, this is all the constraints, all this, see all the constraints, okay, and see there are several choices. All constraints satisfied only, and if I click on this thing, you'll see that there's none, okay, but you're still relatively close to the optimal solution, okay. Now, the other thing is that you can say, okay, show me, let me see now, cancel. See, I clicked on select parameters. Show me how A changes, how B changes as I did my iterations or steps, okay? I don't want to say iteration. And then you say show curves. There. You see, I started with, first step was 6 and 6, right? 6 and 6. And each one of these represents a possibility, and you can see that it's stabilized around 5.14. 5.14. You put the cursor here, you can see it down below in this prompt line, 5.14, and this one is 4.8. Theory says that these have to be 5 and 5. Now, if you want to see for example, the area, how it changed, so select the parameter. I don't want A and B. I want area. Show me the curve. Notice that it stabilized around 5 and 5, or 25 square inches, 25 square millimeters. Okay, good. Now, that's this. Now, what I want to do is I want to go to the constraint. And this constraint that I put down, you double click on it. And instead of saying it's equal to, I'm going to say it's less than or equal to. Less than or equal to. Okay? Less than or equal to. And now I'm going to run. There is there may be some adjustments or uh, some improvement, but this is already pretty good, and there's not much else we can add to that. But anyway, regardless of that, this optimization, product engineering optimization, is something that will lead you in the right direction. It may not get you the exact answer, but it will get you close to it. Okay. Now, what I wanted to do is, let me say, okay. Oh, by the way, when you go to computation result and you select the last one, if you say apply values to the parameter, see this box here, apply that, it put the original, not the original, but the surface that you want of these dimensions, final dimensions. Now, let me say okay. It's right here. See, as soon as you do optimization, the tree adjusts itself, and you double click on this, and you can go and make appropriate changes. And you know, okay. Now, one other thing I want to do is to see what was actually in that Excel file. So let me see now. So maximizing, I think it was this. The Excel file that it created, it basically creates detailed information about the values of A and B and the area, maximum area. Now, in this particular problem, if you go back here, if you look at this, double click on this. In this particular problem, when you click on the constraints tab, you see that it actually never satisfied the constraint. It's supposed to be 25, but it is not 25. Oh, sorry, 20. It's supposed to be 20 millimeter, less than or equal to 22 millimeter, but the value got down to a perimeter less than or equal to 0.002, something like that. If this is green, if this is all green, as you see in the other example, it will be green. That means the constraint is satisfied. But if it's red, it means that the constraint is not completely satisfied. Okay. Now, this weight is also important, but I'm not going to be dealing with it in these tutorials. Now, let's go back here, see what we did. Okay. So if you look at the A and B were the two sides, the dimension of the two sides. And what I have done here, if you did not have any constraint, then basically this is going to be a surface. The area is going to be A times B, which is a surface in the AB plane, some kind of hyperbolic surface in the AB, it's not quite hyperbolic, but it's not a plane. Area is equal to AB is this, okay? Now, when you say A plus B equal to 20 or 2A plus 2B is 20, A plus B is 10, then it means that you are on this surface. You are on this plane, which is erected upward, perpendicular to AB plane. So what you're really looking for is the intersection of these two, which is that green parabola. And the 25 that we got is actually the height of this green parabola. So I just wanted to point out to you what happened in reality. I mean, these are not the kind of thing that I generated. These plots were not generated by Catia. It's just that I'm showing you what happened. Okay, so this was the first problem.